That flashover stage of a fire is essentially when everything in that room gets to its ignition temperature and ignites. Okay, we're not quite there yet, but we're getting close. You can start seeing the off-gassing on the wood here. Our fireman's going to start melting here shortly. Well, probably already is starting to melt. The paper's on fire. This is going to ignite before too long. Okay, so what does fire have to survive? Oxygen, fuel, and what? Heat, right? So what happens if we take one of those away? It goes out, right? So I'm not going to use water. If I'm going to close this opening, what's going to happen to our fire?
It's going to smother.
It's going to smother. Why? You just said it. No oxygen, right? So it's an oxygen-deprived fire. What's the smoke condition telling us right there?
It is nasty.
It's nasty smoke, right? But is it a turbulent smoke or is it a light smoke?
Lightish.
It's pretty light, right? It's kind of puffing out. It's not pushing out a whole lot. It's just kind of light. So as far as when we're reading a building, if we get smoke like this, what's that telling us?
That there's no inflow of air.
There's lack of oxygen. The fire hasn't really got established. You can see that color of it, right? Kind of a darkish brown. Okay. Now going back, what are we missing as far as the fire triangle here? Heat now, right? We smothered it. That gave us a chance for it to cool down. And then remember earlier I said smoke is fuel, right? So in theory, I should be able to light this smoke right here, and it's going to suck it down, and that's going to be the heat that we were missing. And I waited. So there you go. It reignited essentially just through the smoke, right? So when we start talking ventilation or fire attack, size up of buildings, if you have fire, if everything's closed and you have fire blowing out that window, okay, keep in mind that chances are that fire is right inside that window. It doesn't necessarily mean it's deep seated, but that's where it's getting the oxygen and it's actually burning the smoke, okay? So those are a few things to look for. So again, we still haven't quite got to flashover stage. We're gonna let that build up a little bit. I'll throw some more wood in there, because why not? Okay.
And what do you mean by flashover stage? If it
Flashover is when we have full room involvement.
Okay.
So I'd say now we can see that fire kind of right inside here.
yeah,
Okay, obviously we got some clean air coming in here, so it's protecting this area. So you're essentially at flashover stage here. So after that flashover stage of the fire, what's going to start happening to it?
it's going to want to go out.
Yeah, because why? What are we missing at that point? Fuel.
Yeah.
So that takes us into the decay stage of the fire. Okay, so we have the ignition and incipient, which is the start, the growth as it's growing, the rollover, flashover, fully developed essentially, and then it's going to start going into that decay stage.
Boy, you can see the blue smoke coming through kind of the seams and everything, kind of really pushing it out.
Yeah.
And the volume.
Yeah, it's a lot more volatile now, a lot more pressurized as far as up at the roof level, right? Now when we start talking hose streams, okay, I got a straight stream going here. For a fire like this, what are we going to want to do, a straight stream or a fog stream, and why?
A straight stream.
Straight. Okay, why?
Because fog is it's going to just vaporize and floor to ceiling.
Okay, so think about our expansion ratio of water. Okay, what does water expand to? It's 1,000 times to 1. Okay, so when we get a straight stream, each little droplet is close together, right? Compared to a fog stream that pattern's broken up, right? So are we going to get more expansion with a straight or a fog?
Fog.
With a fog. And if we get that expansion, you're right, as far as it steaming, but what's that steam going to essentially do to our fire?
It's cooling it.
It's cooling it as well as suffocating it a little bit. So I'll try and demonstrate with this. Again, it's kind of hard because that's not a lot of water for this. But with a straight stream, you want to go to the seat of the fire, right? That's the goal with a straight stream. And you can see did fairly well, right? There's a little fire in the corner. But again, is that environment still hot enough to reignite?
Yes.
Absolutely. And of course it's not ready. There it goes. So we were able to somewhat reignite it. I'm gonna throw some more wood in there.
So with that, we utilize a smooth bore and a straight stream
Uh-huh.
significantly, but I guess for us, we've always been taught, or the technique is to pencil it off of the ceiling and then let it disperse.
Yep.
And probably maybe get the same effect as the fog.
You do. So even just by, whether it's penciling or doing that O pattern and getting it to whip, you get that same effect as a fog for sure. The one thing with fog, you get a lot more airflow going into it, right? So if you have a fog stream, it's pulling a lot of that clean air behind you. When you start doing that with a smooth bore, the same thing's happening. You're creating that vortex and getting that air going in there as well. Okay. So now I'm gonna show you. Try to show you what a fog stream might do. So you can see, change the pattern a little bit. So somewhat the same effect, right? It was a little bit hotter, had some fire stuck in the corner there, but we got the same outcome. There we go. That was a little better. Notice how I was able to light it from out here that time, because again, the environment inside got a little bit hotter, and it was able to carry in a lot faster. So now we're gonna try and get this really, really hot. Let that burn. Any questions so far? None? Okay. So I'm gonna let this build up. We're gonna try and get it to backdraft. It's gotta be really hot for it to backdraft. And